What's up, everybody? Man, I'm about to open a can of worms with this video that's about to be presented about SWR, feed line length, or rather or not SWR affects, or coax length affects SWR, whether or not resonance affects SWR, whether or not if the lowest SWR occurs at resonance, which it absolutely does not, which will be proven beyond a shadow of a doubt within this video, because you can have a resonant antenna in the multi-thousands of ohms, and if you plug a 50 ohm cable into it, I mean, sorry, but you're going to have skyrocket high SWR, regardless of whether or not that antenna was a resonant. Anyway, I think I already said that in the video that's about to be loaded up here, but there you go, I said it again. Anyway, I'm probably not going to engage in a whole lot in the comments. I think I covered everything pretty fair. If there's complex things in the comments, if I made some mistakes or any real errors, if somebody actually knows what they're talking about, by all means, come on in. But I think I covered everything pretty fair and pretty decent. I didn't go by any notes. This is all just spur of the moment off the top of my head, but while I had the bench clear before I set the next radio up here. I'm about to do a Striker 447, but I figured I'd do this real quick while I had a chance. But I hope y'all enjoy it. I hope somebody gets something out of it. It proves a few things. So, y'all stick around. I'll catch y'all later. What's going on, everybody? I thought it'd be another fun little video here to make about coax length and SWR and resonance and whether or not coax changes your SWR and so on and so forth. So, we're going to play with the Rig Expert here a little bit, and I've got a Motorola dummy load here. And I guess first thing I'm going to do, I'm going to measure the DC resistance. I'm going to measure the DC resistance. Okay? So let's see if I can get this here in the frame. We'll throw it up there. And this piece of coax is terminated into the dummy load there, and I'm just going to measure the DC resistance and see what it says. I shouldn't touch it to do this, but I'm going to touch one side. So there we go, we've got 52.9 ohms. Okay, that's DC resistance. Alright, so we want a dummy load to have a pure resistive, non-inductive load is what we want. Okay? Because inductance and affects your readings. And so we're going to plug the Rig Expert in here. This is a random length of coax. I don't know, it's roughly about 6 feet of mini 8, something like that. It's not tuned or any of that crap. This is Davis RF brand. This is really good cable. I really love this stuff. Davis RF. Davis RF there. This is good stuff, man. I really like this. This is a really old jumper. I made this thing a really long time ago. You can tell, buddy, she's not loose. This thing doesn't move. Remember though, according to some shops, these holes ain't supposed to be soldered. They're for airflow, right? Alright, anyway, and I love these ends right here. None of that junk. Alright, we're going to plug this into the Rig Expert. Just see what it says. That's a Motorola dummy load. It's fired up. We're going to read the all parameters chart. Alright, we've got a little bit of reactance at play. We don't like to have reactance in our dummy loads, but there she is. Our phase angle's running about 15 degrees. So there you go. That's what this dummy load checks out with this, I don't know, somewhere around 6 feet of coax. Just stabbing at it there. Alright, we're on 28, channel 28. I'm not going to worry about changing the frequency really. But I'm going to shut the Rig Expert down now. And I'm going to change coax. Just chunk that in the floor. How about that? Now I've got a nice little short piece of cable here. This one's only about 3 feet. There we go. Same Amphenol ends. Oh no, it ain't either. These are knockoffs. Anyway, she's good. She don't wiggle. This is good jumper. Soldered as usual. This is about a 3-foot one. We're going to see what this piece of coax tells us. Y'all think it's going to change? I know it will. Because there's reactance at play. Look at that. Now we've got 48.6 ohms. Now we've got reactance taken away from the load. Look at that. Of course, a different phase angle. Much shorter piece of cable. So does this length of coax actually change our SWR? That's the real question here. A lot of people argue whether or not an impedance transformation is taking place or not. Well, sometimes it can, sometimes it doesn't. If this was terminated into an antenna that was reactive, does the actual impedance at feed point, is it transformed or not because of coax? Well, the answer is yes, it is. But that does not mean that there is not a standing wave on your cable. There is still a standing wave on your cable. Does that mean that it's going to be radiated or reflected back to your antenna? It all depends on phase angle. So, is there a mismatch if you're feeding an antenna that's reactive with random lengths of cable, or is there, can you improve your SWR? Can you improve the, and as far as resonance and stuff is concerned, here, I've got something else here to show. I'm going to show my beam, my antenna, and this thing isn't tuned for crap. I really don't care. I run tube type equipment. My equipment loads into it, so it runs just fine. Let's see if I can get this coax over here. Alright, this is my beam. And we'll check it out. We'll check out where it's resonant at and where it's not. My antenna is not resonant where I run it at. Where I run it on 28. This thing, I got it good enough to use, and I left it alone. So right there's channel 28, and that's actually a terrible tune, and I know that, and I really don't care at the moment. I talk on it, I get out, it works fine, my crap loads up into it, you know. It is what it is. It's like the mechanic driving the broke down car all the time. Now let's see where this antenna is actually resonant at. Now remember, we've got an SWR of 1.4 and our load is 42 ohms, 42 and a half ohms. And we are not resonant. X factor 13, that is not resonant. Okay? So let's look at something. Let's look at where... Geez, I can't freaking see what I'm doing. Where's the RX chart? There it is. Alright, now let's run that. Now that tells me we're resonant at 26,901. So let's see what the SWR is at 26,901. And then the all parameters. There's 26,905. Close enough. Let's run it. And there's where it's resonant at. We've got X factors almost 0. Our phase angle is almost 180. Check that out. Isn't that coincidental? And our SWR has went up. Does that make sense to very many people? It makes perfect sense to me, because resonance has absolutely nothing to do with your SWR. You can have a resonant antenna that is in the thousands of ohms. Will that present a good SWR on a 50 ohm feed line? Absolutely not. But does it mean that the antenna isn't resonant? Nope. SWR going to be through the roof if you hook a resonant in-fed antenna straight to a piece of coax. But the moral of the story is resonance has nothing to do with SWR. You can clearly see right here where my antenna is resonant at, my SWR is worse. And that's because reactance will add or subtract from the Z, from the load of the antenna. It will add or subtract ohms to that load. That's what reactance does. When an antenna becomes reactive, lengths of 50 ohm cable transforms impedances. That's why your cable makes a difference on what your readings are. Whenever you're tuning an antenna, you should use a tuned half wavelength piece of cable that presents 180 ohm phase angle, 180 degree phase angle. And that should be your, and what that does, it gives the reciprocal, it mirrors, it's a mirror, it's not the impedance, it's the mirrored impedance, it's the mirrored load of the feed point. 180 degrees, okay, that's what you want. So you tune your antenna with a tuned half wavelength piece of cable, and you get the reactance to 0. Whatever the ohms are is what they are. And then you've got a matching network that needs to be tuned. You know, you do your reactance with length, and they all, you know, kind of play into each other's. But you want the 180 ohm phase angle when you're tuning the antenna, and you want to tune for X0 with that half wavelength piece of cable. Once the antenna is tuned with a half wavelength piece of cable and there's no more reactance at play, once the reactance is gone, feed line will no longer act as an impedance transformer, so long as you got the feed point of the antenna at 50 ohms through that half wavelength tuned piece of cable with X factor 0. Then you can run any length of cable you want, and it will not affect the overall system, other than, of course, additional feed line loss and some series resistance. But other than those small degree of changes, nothing major is going to happen, like I demonstrated with my reactive dummy load, having a pretty drastic change. But there we go. There's the moral of the story. Quick little rundown on some SWR and cable lengths and so on and so forth, and reactance and resonance not having anything to do with your SWR. Y'all have a good one. I hope somebody got something out of this and it made a little bit of sense. Catch y'all later.